Que Windows 7 sea realmente una versión de Windows muy rápida y muy eficiente, y que de hecho Windows Server 2008 también incorpore mejoras importantes desde el punto de vista de rendimiento, no es casualidad. ¿Por qué? Porque desde hace ya unos cuantos años existe una iniciativa mediante la cual el kernel, el core de Windows Cliente y Windows Server está siendo construida por un mismo grupo de producto. Para nosotros es un honor realmente tener hoy día a Dave Probert, uno de los arquitectos del kernel de Windows, para que les cuente justamente cuáles son las novedades y cuáles son las nuevas capacidades y características que incorpora el Windows kernel, tanto para Windows 7 como para Windows Server 2008. So Dave va a estar hablando en inglés. Arriba en la pantalla de arriba van a tener la traducción con los subtítulos. Thank you very much.
Thank you. So at the heart of Windows 7 and Windows Server 2008 R2 is the kernel and the hypervisor. And the same kernel is actually used for both the client operating system and for the server operating system. It's much easier for us to test and develop that way. Some features are turned on in server and not available in client, but it's basically the same system. If you are running Windows 7, and many of you are running the release candidate, you've probably noticed that the version of the operating system is 6.1. The reason for that is not because there has been so little change, but because so many applications like to check for the version number that we didn't want to break applications simply by changing the version number. As you'll see in the next few minutes, there's a lot of new things that have gone into the core of the system. These are spread out into a number of different areas in terms of how we've componentized the system, performance, power efficiency, a lot of things, and I'm only going to cover a few of them in these few minutes, but there's another talk that I'll give at 2 o'clock in the breakout session where we'll go into much more detail. One of the things that we worked very hard on the last several releases, really starting right after Windows 2000 shipped, when we finished that in 1999, was to improve our engineering processes so that we could better manage the complexity of the system that does so many things for so many different kinds of applications just throughout the world. And the thing that you will see in Windows 7 is that we have partitioned the system into different layers so that we could manage the complexity of the system more effectively. And perhaps you've heard of MinWin. How many people have heard of MinWin? How many people think MinWin has anything to do with microkernels? Yes, not at all. In fact, MinWin is something that even though Windows is now built using this partitioning, it's not something that you would see except as the result of the better processes that we have in place. So by understanding the layering of the system, we took part of the system and we now build it separately and then link it together, building the rest of the system on top. And so it's really a subdivision of Windows, and this is underneath a lot of our new engineering processes. Now, along the way, we've also gotten more sophisticated at how we deal with memory in Windows. I think for a long time we were riding the curve of increasing memory sizes, increasing CPU capacities, and now at the time of Windows 7 we're now going the other way. We're starting to use less memory in the system, we're starting to deliver better performance even on slower processors. How many of you have used Vista on a netbook? Anybody use Vista on a netbook? Anybody use Windows 7 on a netbook yet? Much better? Doesn't it work much better? Yes. We spent a lot of time reducing the footprint, and this is also true in the server space. One of the measures of how much memory we're using is how many pages that we're having to reference from the system. And this table here shows the improvement even when the system is idle in terms of the amount of memory that we're using.
Dave, so can you speak more slowly, please?
Yes, I saw that. So the translators have requested I slow down, which I was afraid they would do. So we've also made improvements in the area of power management. As we get more and more processors in the coming years, we're having to be far more careful about how we use them in order to not consume too much energy. Energy translates into battery life for consumer products, but it translates into lots and lots of dollars for power and cooling for servers. So starting with Windows Server 2008 R2, we've really upped the ante for core parking. So this is an illustration of how core parking works. It used to be in the operating system that we would try and spread out the work evenly across the processors to maximize performance, even if we were not heavily using the processors. But now with core parking, we'll actually move work off of processors so that we can turn off the power to them if they're not being heavily utilized. If more work appears in the system, we can then put it on the processors that we have turned down, and they'll come back to life again. So this is core parking. We've also done some work with timers. It turns out that many of us in operating systems made a mistake a long time ago, and that we would design APIs so that programmers could say, I would like you to do something 10 hours from now. But we would have them say, I'd like you to do something 10 hours, 0 minutes, 0 seconds, 0 milliseconds from now, and be very precise. And when it comes to different kinds of activities in the system, that means the system must constantly wake up to service these timer requests. So we've now introduced new APIs that allow the programmer to say, more or less 10 hours, somewhere in that vicinity. Do this every minute, more or less. And that allows us, as you can see in this diagram, to take many events and do them all at the same time. And that allows the CPUs to go to sleep